In this video, we will be writing systems of equations. I'm going to go over some vocabulary and we will write some systems of equations and solve them. First, let's talk about some of the vocabulary. Certain vocabulary words mean specific math symbols or math operations. We will use an equal sign when we see the word is or had or actually any verb. For example, X is 26. We write X equals 26. Ben had 20 CDs. B equals 20. Ben weighs 260 pounds. B equals 260. We would use the plus sign for addition when we see more than, like in y equals, or y is 2 more than x. So see how it's kind of written backwards, 2 more than x? So we write y equals x plus 2. Or the words the sum of, that means add numbers together. So y is the sum of x and 2. We know we're adding the x and the 2. We're going to use a subtraction symbol when we see the words less than or the difference of. So written backwards, y is 2 less than x. So we would write y equals x minus 2 here. Or the difference of, y is the difference of these two numbers, x and 2. So y equals x minus 2. Some weirdly worded things. There are 5 more rocks than scissors. So we know that there's 5 more rocks than scissors. So if we take the scissors and add 5 to them, we're going to have the rocks. You have to kind of think through that. There are 3 less scissors than paper. So if I take the scissors and I subtract 3 from the paper, then I'll have 3 less scissors than paper. Ben has 3 times as many DVDs as Kevin. 3 times as many DVDs as Kevin. So here we'd have to multiply Kevin's DVDs by 3 to get Ben. And another type of helpful hint, if you have $3 signs or 3 pieces of money, they're all going to go in one equation. Okay, so let's look at some examples. First, I want to just start off writing an equation using from the words, not the system just yet. All right, so here we have the width of a rectangle is 2 centimeters less than its length. So we know that the width of a rectangle is less than its length, 2 centimeters less than its length. So here, if you think about it, we know that our length is bigger. So if we take the length and we subtract 2 from it, we'll have the width of a rectangle is 2 centimeters less than its length. The length of a rectangle is 5 more than its width. So if we take our width and add 5, that's how we get that one. The number of boys is 10 less than the number of girls. So to get the boys, we take the girls and we're going to subtract 10. The number of CDs is 23 more than the number of DVDs. So we have CDs is more than the DVDs. So if I write D plus and then 23. Okay? We are still writing equations from the words, but now we're going to have 2 equations so we can solve the system of equations. All right, so first of all, we have a rectangle has a perimeter of 36 centimeters. Its width is 4 centimeters less than its length. So I know how to write perimeter of a rectangle. So the perimeter is going to be equal to 2 of the lengths plus 2 of the widths. So that's our formula. And so that'll be one of our equations. And the width is 4 centimeters less than its length. So I take the length and I subtract 4. And so now we have our system of equations, but we need to find the length of our rectangle and then put it into our grid. So right up here, I forgot to put the actual 36. So I'm going to write equals 36. So these are our two equations. Okay. So I'm going to use substitution. So I'm going to replace the W in this equation right here with what W is equal to. All right. So I'm going to replace this W with this W. Okay. So we have 2L plus 2 times L minus 4 equals 36. And I'm going to solve for L. So 2L minus 8 plus 2L. So now I have 4L minus 8 equals 36. So we're going to add 8 to both sides. And I get 44 equals 4L. And now divide both sides by 4. We have L equals 11. So the length is 11. Is that what it's asking us for? Yes. So now I'm going to place it in the grid and bubble it in. When we have positive numbers, we don't have to fill in the plus sign, but if you get in the habit of it, you won't forget to do it when it's time to do a negative one. All right, let's look at their next one. Monica purchased a porch that contained 2 different colors of brick to create a neat pattern. She purchased the red bricks at $2 each and the gray bricks for $3 each. Write a system of equations that could be used to find the number of each type of brick Monica purchased if she spent $160 on 60 bricks. Solve and to determine the number of gray bricks Monica used. All right, so I know we have red bricks were $2 and gray bricks were $3. They all cost $160, and she bought 60 bricks. That's all important information. And then, of course, our final thing is how many gray bricks did she use? Is going to be our final answer. $2 for red bricks plus $3 for gray bricks is going to equal $160. So all 3 monies are going to go in the same equation, just like it said on the first slide. And then our total number of red and gray bricks is 60. It's our total number. So we just add them together. All right, so here I'm going to use substitution again. So I want to solve one of my variables for the other. And I want to solve, so I still have the gray. So let's solve for the R. And we'll have an equation where we're solving for gray. All right, so I'm going to subtract gray from both sides. And so R is equal to 60 minus the gray bricks. And so I'm going to take this equation right here, this R value, and plug it into this equation here. Okay, so I have 2 times 60 minus G plus 3G equals 160. And this is where I put the 60 minus G instead of the R. And now I'm going to solve for G. First I'm going to distribute. All right, so G is equal to 40. Is this what we are being asked for? G stands for the gray bricks, And so, yes, G is 40. So we'll write in our 40 and color it in. And again, you don't have to put the plus, but sometimes if we get used to doing that, then we don't forget to put the minus when it's time for the negative symbol. Okay, just a couple more examples. A manager purchased a total of 21 coffee mugs and keychains. All right, so we have mugs plus keychains equals 21. Each coffee mug cost $8.50 and each keychain cost $2.75. If the manager spent a total of $132.50, how many mugs did the manager purchase? All right, so we have $8.50 times mugs plus $2.75 times the keychains is going to equal $132.50. So we're solving using substitution. So I want to know how many mugs I have, so I'm going to solve for K so that I keep the mugs in my equation. So here I will subtract M from both sides, and I get K is equal to 21 minus M. All right, and then I'm going to substitute this K value in for this right here. So we'll rewrite this equation with the substitution in it. So next step is to distribute. So I have 275 times 21, which is 57.75, minus 2.75 M. And then of course we still have the 850 M. Okay, so now we're going to combine our like terms. 850 minus 275 is 575, plus 5775 is going to equal 132.50. All right, so my next step, I'm going to go ahead and bring this over here. 575. Okay, so we're going to subtract the 5775 from both sides of our equation. And we're left with 5.75 M equals 74.75. And then now we'll divide both sides by our 5.75, and we're going to have the number of mugs that they bought. And we get M equals 13. And the M stands for the 13 mugs. All right, so we'll color that in our 13. And I'm going to color in the positive because it's not negative, and I want to make sure I'm in the habit of doing that. For these last two examples, we're just going to write the system of equations. Okay, so we have 3 bananas and 2 oranges sell for $1.25. So 3 bananas plus 2 oranges sell for $1.25. 5 bananas and 1 orange sell for $1.50. What is the cost for each type of fruit? All right, so we need to have, we don't know if they used X for bananas or Y for bananas. So we have to look at each one. And if we get the 3, we have to have the 3 and the 5 have to have the same variable. So here I have a 3 and a 5, and then the 2 and the 1, and the 150 and 125 and the 150. So that one looks right. This one has a 2 and a 5 for the same variable, and we need the 3 and the 5 to be the same variable, so it's not that one. Again, 2 and 5, it's not that one. Here's a 3 and a 5, a 2 and a 1, but the 150 is not on the right equation. So this is going to be our answer. All right, let's look at the next example, which is on the next slide, and then we'll be done. Okay, a bag of 18 coins consisting of quarters and dimes. The total value of the coins is $2.85. Which system of equations can be used to determine the number of quarters and the number of dimes in the bag? Okay, so remember that quarters are equal to 25 cents and dimes are 10 cents, like this, okay? So you have to be careful that it doesn't say 10 or 01 or something like that. All right, so when we have 18 coins, so we have quarters plus dimes is going to equal 18. So we can already cross off these two equations because they have the quarters and dimes equaling money. And now we know that the 0.25 should be with the quarters. 0.25Q plus the 0.10D is equal to $2.85. Okay, so we know that quarters is not 10 cents, okay? And dimes are not 25, so it's not that one. And here we do have quarters are 25 cents, the dimes are 10 cents, and the money's right. So here we have the correct answer. Hope this is helpful.